Good day everyone, my name is Jesler DELOS Santos from BET-CpET 2BM, and for today's video, we will be conducting Experiment 7 XOR Gate. For the objectives of the experiment, number 1, to examine a TTL XOR gate's features and function. Number 2, to combine many 2-input TTL XOR gates to create a logic circuit with an enlarged input and outputs. Now that we're done with the objectives, let's continue with the materials. So for the materials of the experiment, we have 2.5 volt power supply. I used 2.5 volts because when I tested it in Tinkercad and used 5 volts, the IC burned. 1 piece 74LS86, 6 pieces SPDT toggle switch, 6 pieces 5mm red LED, and 4 pieces 5.1k ohms resistor. So now that we're done with the materials, let's continue with the circuit design. This is what our circuit design looks like, and if we look closely, we have split the circuit into two for us to have two separate truth tables. The first truth table uses only one NAND gate, 2 switches, and 3 LEDs. The second truth table uses 3 NAND gates, 4 switches, and 3 LEDs. Now that we're done with the circuit design, let's go ahead and test truth table A. So let's start with the first truth table. This is D1, D2, IN1, IN2, and IN3. So this side is the first half of the truth table. So I used 2.5 volts in my PSU because when I tested it in Tinkercad and I used 5 volts, the IC burned. So now let's use 2.5 volts. So we have 0, 0 and 0, 0, 0 for the output. We have 0, 1. We have 0, 1, 1 for the output. We have 1, 0 and 1, 0, 1 for the output. And lastly, we have 1, 1 and 1, 1, 0 for the output. So these two LEDs represents the status of the LED of the switch. So if I turn on this switch, as you can see, this LED turns on. And if I turn on this switch, this LED turns on. This LED is the original output of the XOR gate. So 0, 0, 0, 0, 1, 1, 1, 0, 1, and 1, 1, 0. So this is the true output of the XOR gate. So this is what our first truth table looks like. As I mentioned earlier, IN3 is the only output that represents XOR gate logic functions. IN1 and IN2 only represents the status of D1 and D2. So we have proved that the first truth table has XOR gate Boolean functions. Now that we're done with truth table A, let's go ahead and continue with truth table B. This is for truth table B. So this is the 4 inputs, and then this is the 3 outputs. So this is D3, D4, D5, and D6. This is IN4, IN5, and IN6. So first, for the truth table, we have D30, D40, D50, and D60. So we have 0, 0, 0 for the outputs. And then we have 0, 0, 0, 1. We have 0, 0, 1 for the outputs. And then next we have 0, 0, 1, 0. We have 0, 1, 1 for the outputs. And then we have 0, 0, 1, 1. We have 0, 1, 0 for the output. And then 0, 1, 0, 0. We have 1, 1, 1 for the output. And then 0, 1, 0, 1. We have 1, 1, 0 for the outputs. And then 0, 1, 1, 0. We have 1, 0, 0 for the output. Then we have 0, 1, 1, 1. 1, 0, 1 for the output. And then we have 1, 0, 0, 0. 1 1 1 for the output. We have 1 0 0 1 1 1 0 for the output. We have 1 0 1 0. We have 1 0 0 for the output. And then 1 0 1 1 1 0 1 for the output. And then 1 1 0 0 0 0 0 is the output. That, and then next we have 1 1 0 1. We have 0 0 1 for the output. And then we have 1 1. We have 1 1 1 0 0 1 1 for the output. And then lastly 1 1 1 1. And then 0 1 0 for the output. So that is for circuit and truth table B. So this is what our second truth table looks like. This very much represents XOR gate Boolean functions when we have a 4 input and 3 output XOR gate circuit. So we proved that this second truth table has XOR gate Boolean functions.